Hello everyone, welcome to the first lesson in our proportional relationships unit. So, when are you ever going to use this in real life? Proportions are when everything changes by the same amount each time. So that's actually what we just did when we were cooking for our recipe. So when you're cooking or you have to change a recipe, everything changes by the same amount. So let's say you double the recipe, you would multiply everything by 2. That means that your recipe is proportional because we are multiplying everything by the same amount to get our new recipe. Same idea for when you're doing a scale drawing. So that's where we take something that's usually really big and we draw a smaller version of it. So when you do that, you take all the measurements and divide by the same amount to get your smaller version. Since it's the same amount, that makes it proportional. Part of this unit will also be taking tables, graphs, and equations and being able to write those other representations when given one of them. So we're going to take data and write them in different ways. We'll write tables as graphs. We'll write any written information as a table, and so on until we have all of our different representations. Some jobs that use this topic: economists are slope when we talk about it then. Will also come up in Algebra 1 and in Algebra 2. Okay, let's talk about what it means for something to be proportional. So two quantities are So let's say I have this fraction 1/2. I want fractions that are proportional to 1/2. So those are going to be fractions that equal 1/2, but we use different numbers to show that. So for example, we could have 2/4. That is proportional to 1/2 because bottom by 3. We could do 25/50, multiplying top and bottom by 25, and so on. So a little practice question to get us thinking about proportions. So Harrison travels 180 miles in 2.5 hours. How many miles of miles, 180, and divide by the number of hours, which is 2.5. If we do 180 divided by 2 miles in 1 hour. So every time he drives another hour, he's going 72 more miles. So when he gets consistently increased by 72 each time, this is proportional, and this number is known as the constant of proportionality. Value of the ratio between two proportional quantities. Amount a rate changes each time. So like Harrison's car was going 72 miles every single hour. It's changing by 72 every time. We also call this a rate of change. Again, it's how much the rate. if we ever want to find the constant of proportionality, we say, okay, k is, and then we take whatever the y value is, divided by the x values. So y is any y values in our table and graph. More on our next page. On the next page here, so this table shows feet, that's our x value, and inches, that's our y value. What we're going to do is, when you do y divided by x, we want to know what we get. So we're going to fill this column in right here. So y is 12, x is 1, so we're going to do 12 divided by 1. Next row, I have 24 divided by 2. 24 divided by 2 is also 12. Next row, 36 divided by 3. Second and fill in the next 2 rows. So you'll notice each row we got 12. So y divided by x is 12. Then it says, how do you know the number? That value is 12. So inches changes by you can also say y divided by x is always 12. That's also a good way to describe that it's proportional. This amount right here. You can do this a couple ways. You can notice that we're increasing by 12 each time. So that means my next value is just 12 bigger than 16. Is that, hey, we're just taking the x value and multiplying by 12 to get that y value. So that means when I have this x value, I can multiply by 12 and get the y value. So you have 260 plus 12. Either way is going to get you the correct answer. This part here, using x, the number of feet, how do you find y, the number of inches? That's what we just talked about. If you know the feet, x by 12 to get y. This leads us into building an equation for this. Times x. That can also just be written as 12x. That's my equation. The general form for this equation k in this last part, we just replace the k with whatever that constant of proportionality is. In case you forget, y is any y values, k is the constant and x is the x values. Okay. Let's do another question. While training, so here's how many miles he ran, here's how many calories he burned. Calories is y, miles is x. First it says, is the number of calories proportional to the number of miles? To figure that out, I need to do y divided by x. I divide by the x, which is 1. So 117 divided by 1 is 117. Next area, I take my y, which is 234. I divide by x, which is 2. That is also 117. So we see our reasoning is because y divided by x is 117 every time. If there was ever a time where it wasn't proportionality, remember that's just what is y divided by x. We get 117. Our equation, we're remembering we're going to use y equals kx, so we're just going to y equals 117x. And then last part here, the next day Lincoln ran 7.5 miles. How many calories did he burn? We could extend our table and find 6 and 7 and 8 x value, that's what this is, multiply it by our constant proportionality, 117, and get our y. So I can literally say, okay, y is whatever 117 177.5 calories. All right, on day, they're all going to be proportional. So that means when I do y divided by x, I'm going to get the same thing. That won't be true for all of the for this table. First, I look at my y's and then my x's. I'm going to find y divided by x. So I'm going to do 6 divided by 1.5. That gives us 4. I'm going to go do the divided by 4 is my x. That gives me 4. Next up, 22 divided by 5.5. That's also 4. And finally, 30 divided by 7. The value is 4. And our equation is y equals 4x. I just replace the 4 with where we would normally have that k in the general form of the equation. Practice them in a second. I'd like to look at the graphs on the next page. So, same idea, we're still going to do y divided by x, but we now have the information just presented to us in a different way. So here's our y-axis, here's our x-axis. I'm going to pick a point, I'm going to take the value, so I just slide over to the left. The y value is 1, and if I slide down, the x value is 2, so I'm doing 1 divided by 2. Just so we're clear, there's a couple points on here I actually wouldn't want to use when I do this. I would not want this second point, because if I slide over, it's really hard to tell exactly the value. I could guess that it's 1.5, but I could be wrong. So I would not use that point, and I would also not use this point, just because it's not on a whole number for those y values. These other 2 points would also work perfectly fine. 1 divided by 2, that gives us 0.5. So k is 0.5. And our equation x. Let's try another one. So here's our y-axis and here's our x-axis. I'm picking a point. I'll take this one. I'm going to slide over and get my y value. Which means the number just between 4 and 8 is just going to be a 6. And then I slide down to my x values. My x is at 5. So I do 6 divided by 5, I should get 1.2. So the k value is 1.2. To x. Alright, I'm going to have you pause the video and you're going to do some practice questions. So you are going to go back and do 2 through 5, and then you're going to do 9 through interested. Okay? So pause the video and do those questions now. Here's the answers for 2 through 5. Here's 2, 3, and 4. Down here is 5. Here's 11 and 12. I changed the graph for 12, but your answers are still 3 and y equals 3x. If you have any questions, let me know. Otherwise, have a great day.